Well, what if I want to solve a polynomial inequality and I don't have the graph? I want to do it algebraically. That's what we're going to cover in this video. So here I have the polynomial function 9x squared minus 2 greater than or equal to negative 3x. The very first thing that we want to do is gather all of my terms up on the same side and set it either greater than or equal to 0. So I'm going to gather my, I'm going to add 3x to the left-hand side, and I have 9x squared plus 3x minus 2 greater than or equal to 0. And I went ahead and wrote it in descending order because the next thing I have to do is to solve this function to find its roots. We do that by solving this quadratic. So I have, I'm going to just try this using trial and error, greater than or equal to 0. And I know that this sign says that I have to have a positive and a negative. There are only one set of factors for 2, and I'm going to take a guess on 3x and 3x to be the factors for 9x squared. So let's see if I have this in the right order. I have minus 3x plus 6x gives me a plus 3x. Now most everybody can get the factors for the last term correct here. They get the factors for the first term correct here, but they may not have the right middle term. So always check your outer and your inner gives you back the middle. So here I have my function factored. I can now set each of the factors equal to 0. So 3x plus 2 equals 0. 3x minus 1 equals 0. And I'm solving this, so I'm going to take away that inequality symbol and put it equals. So I'm going to subtract 2 to the right-hand side. 3x is negative 2, so x is negative 2/3. And 3x is 1, so x is equal to 1/3. We're going to take these, remember these are the roots of my function. This is where I'm crossing or touching the x-axis. And I happen to know, since these are the multiplicity of these factors is 1, that we are going to be crossing the x-axis. But what we're going to do is we're going to take these roots and we're going to draw them on a number line. Okay? So I have negative 2/3 here. I have positive 1/3 here. And what we're doing when we do this to the roots is I'm trying to pick test values to the left, in the center, and to the right of where my function is crossing the x-axis, so I know whether or not it's above or below. That's what we're doing this for. Now, once I write my numbers on the number line, since I'm looking, ultimately I'm going to be looking for what interval that I need to cause that's going to give me a solution, I go ahead and write my intervals here on my number line just so that I don't forget them. If I'm to the left of negative 2/3, then I'm talking about values from negative infinity to negative 2/3, and because the symbol in my original statement is this, then I can use a bracket. Parentheses always occur around infinity, but still. In between, I might be talking about negative 2/3 and 1/3 with a bracket. So in between negative 2/3 and 1/3, that interval looks like this. To the right, I would have 1/3 to positive infinity with a parentheses. And that's how my number line would be divided up. Now, we're going to pick test values that are to the left of negative 2/3. Well, the easiest one I'm going to pick is negative 1. In the center, I need to pick some number that is between negative 2/3 and positive 1/3. Well, the next easiest number would be 0. And on the right, I'm going to pick a number to the right of 1/3, and that would be positive 1. So those are just the easiest numbers that I've chosen. You can pick whatever numbers you want as long as they're on the left of negative 2/3, they're in the middle, or they're on the right, because you know we're just picking numbers here. Now I'm going to take this first number and I am going to plug it into my function, and I'm going to evaluate the function at negative 1. Now my function, don't forget, was 9x squared plus 3x minus 2. So I am going to plug in -1 everywhere there's an x and simplify. When you do that, you'll find that you get 4. And 4 is obviously positive. Now you go back in and you plug in 0 into this function. So that would be 0 plus 0 minus 2 would be -2, which is a negative value. Now we're going to test what happens to my function when I replace it with 1. So that's 9 plus 3 minus 2 equals 10, which is positive. Now I was looking for, when this whole thing started, where my function is greater than or equal to 0. So I'm looking for where my function is above the x-axis or positive. You can look here that when I am on the interval when I'm on this interval right here, I'm positive, and when I'm on this interval over here, I'm positive. So my solution would be from -infinity to -2/3 union 1/3 to infinity. And I can graph the solution by drawing my number line down here. So I want to graph the solution set, in other words. So I have -2/3 and 1/3 again. Here this says that I know that I've got values to the left of -2/3, to the right of positive 1/3, and I just simply replace it with my symbols down here. So this in red is the solution, and this here on the graph is the graphic solution to solving this polynomial inequality.